Okay, this is week 6, the second hour. We're going to continue our discussion regarding data mining and warehousing, regarding classification to be more specific, which is the first type of machine learning that we are learning in this course. And we already discussed introduced what classification is, what are the problems associated with classification, and now we're going to talk about classification algorithms. So we have many classification algorithms or techniques that we use, such as the decision tree, the rule-based method. We have the neural networks, we have the naive-Bayes and Bayesian networks. We also have the SVM or the support vector machines. In the rest of this lecture and the beginning of next lecture, we're going to talk about decision tree based methods, and we will finish the chapter by discussing rule-based methods next week, inshallah. Now, when we want to classify using decision tree, we actually use a tree, and a tree is a construction or a structure that consists of branches. It has a root and also it has branches, and it keeps branching down. Now, here the decision tree is actually a flow chart, like a tree structure, and you study trees أكيد in algorithm design or any similar course. Now, the tree will actually have a root, and it will also have branches, and the branches will have branches. Now, the internal nodes, so we'll have the root node and we have internal nodes. The root nodes are actually tests or on attributes, okay? And the branches will actually represent the outcome from the test. It can be yes or no, or it can be true or false, or it can be senior divorced, senior junior. It can be, so this can be, the branch will be an outcome. And then the branch will lead either to another node, which is another test, or a leaf node, which is representing the class. So it will represent the decision. Now, that decision tree actually has two phases. When we want to generate a decision tree, we go through two phases. We go through the tree construction phase and the tree pruning phase. And in today's lecture, we're only going to see the tree construction phase and how we do that. The tree construction phase, at the beginning, we will be considering all the training examples, or all the attributes are at the root. So we'll be starting with the whole set of attributes, and we will be selecting one of them to be representing the root. Then we will be partitioning the examples recursively based on selected attributes, and we will see that in demonstration multiple examples in a minute. But the idea is that when we start by a certain attribute, we need to move to the other attributes out as we move on with branching. Now, tree pruning is actually to identify and remove the branches that are considered to be outliers or noise. So we will have some branches that are outliers, so we'll be removing them, and this is what we call as pruning, which means that cutting branches. And then after we have generated the decision tree, we use the decision tree to classify unknown samples or unseen data. And in this way, we will test the attribute values of the test data against the decision tree to see if the decision tree is capable of predicting the classification of the unseen data. Now, this is an example, and we've seen many like it before. It consists of, we have RID, we have age, income, student, credit rating, and then this is the class will be Bayes computer. So Bayes computer can be either yes or no. And these are the attributes that we want to use in order to determine if that certain customer will actually buy a computer or not. So age has three values: youth, middle-aged, or senior. Income has high, medium, or low. Student has no or yes. And credit rating, we have fair, excellent. Yeah, that's only. So only fair and or excellent. And then the class will be saying yes, they will be buying a computer, or no, they will not buy a computer. Now we want to construct a decision tree based on this training data set in order to predict new customers that do not exist in this data set, and we want to see, or we want to use the classifier to say if this new customer is going to buy a computer or not. Now this is the decision tree that comes out of the data, the training data that we have. So we start by age. So age can be youth, middle-aged, or senior. Now if the age is youth, okay, we're not able to determine or to classify based on youth only if the customer is going to buy the computer or not. If the age is senior, same problem. We're not able to classify directly if the customer will buy a computer or not. However, if the age is middle-aged, we always have yes, based on the training set. It's not a logical deduction here. It doesn't have anything to do with what we believe. It's only based on the data that we have, on our training data, that if the age is middle-aged, then they will be buying computers. Now, if the age is youth, we need to look at another attribute value to be able to determine. So if the age is youth, we need to know if it's a student or not. If it's a student, then yes, they will buy a computer. If it's not a student, then no, they will not buy a computer. Now, seniors are judged based on credit rating. So if their credit rating is excellent, they will not buy a computer. And if their credit rating is fair, they will buy a computer. So as I said, this has nothing to do with what we think. It's about what the data is telling us. So it's telling us actually that seniors with fair credit rating will actually buy computers, and middle age will always buy computers, and youth who are students will also buy computers. And the cases where they will not buy a computer is that the senior with excellent credit rating and the youth who is not student. Now, in order to create the decision tree, we actually follow a basic algorithm that is called a greedy algorithm. There are many approaches to create the tree, but we will talk about the greedy algorithm in particular. So as I said, we will start by constructing, or by a top-down recursive divide and conquer manner. So this is the approach. It's called top-down because we start from the root to the bottom. Okay, and it's recursive divide and conquer because we will be dividing the data based on the attribute values. At the beginning, we will have all the training samples in the root. Now, attributes, they have to be categorical. If they are continuous values, if they are numbers, then we need to discretize them, meaning that they need to be discreted. If you remember from last lecture, if the values are not categorical, we will have to come up with a way to categorize them, and we have to have done that in the pre-processing step. Now we start partitioning the examples that we have based on selected attributes. So if we select a certain attribute, we will start partitioning the data based on that. And then we will test the attributes that we select based on some measures. This can be statistical measures, this can be heuristic measures, and we will learn about these measures later on. An example of these measures is information gain. Now, this is what we are doing when we are constructing the algorithm, and it is called the greedy algorithm. Now, we also need to know, or we need to decide what are the conditions to stop partitioning. So we cannot go partitioning forever. Now, we stop partitioning if we have all samples for a given node belong to the same class. So we end up with having, for instance, as we said, all middle-aged having yes. So do we have to, all middle-aged will buy a computer. So do we have to continue partitioning in this case? No. We have received to a stage where a certain samples, or all samples that belong to this node, all of them actually belong to the same class. So there's no need for further partitioning. Now, also that we do not have any more attributes for further partitioning. We already used all the attributes in the partitioning. So in this case, we actually have answered or used all the attributes, so we will need to stop partitioning. And also, we do not have further samples. We're finished with the samples. So either we have all samples or all tuples belonging to a certain node that were already classified to a single class. We don't have more attributes to partition, and we do not have more samples to use in the partitioning. Now, this is an example for decision tree. Again, we have, this is a categorical data, and here's a continuous data, and we will see how this continuous attribute will be discretized in order to use it with the decision tree. And this is the class. So refund, yes or no, categorical marital state, we have single, married, or divorced, and we have taxable income, and we have various numbers here. And the class is that they cheated in their tax submission or not. So it's either yes or no. Now we will start by the refund. Why do we start by refund? There is no preference here. You can start using any attribute you want, and you will see that for a single training data you can have multiple decision trees, and they will all be doing the same job. Now, first of all, refund has two values, yes or no. Okay, now refund yes, if you see that refund yes, so the person is actually refunding, providing refunds for their taxes. This means that they are not cheating. So no, no, no. No matter what marital state they are and what taxable income they are, it's always no. So this is done. So refund yes, and this means they're not cheating. Refund no, then we'll have to see the other attributes. Now we will see the marital status. The marital status, if they are married, okay, if, refund no, we're done with the yeses. The refund no, and they are married, it's always no. So refund no, and they are married, it's always no. Then we do not need to go further into partitioning here. We're done. Now here we will move to the other, which is single or divorced. Single or divorced, we'll have to look at the tax income. The tax income is a continuous attribute. We need to discretize it in a way or another. Here, they've chosen that if it's less than 80, of course, guided by the data, if it's less than 80,000, then no. Let's see, taxable income less than 80,000, and it's also single, then it's no. Less than 80,000, no. Less than 80,000, no. It's more than 80,000. Less than 80,000, and also it's but it's married here, so it does not apply. So they choose 80,000. You can say less than 75,000. That would be okay, because it's already within this category, single or married. But they choose 80,000, so it's fine, no problem. 80,000, then no. More than 80,000, then yes. If their taxable income is more than 80,000, then it's more likely they will be cheating. So this is how we constructed the decision tree from this training data. Now, this is another decision tree from the same data sample, but or training data. But in this case, we started by the marital status, and this is exactly an equivalent of the other data, the other decision tree, and will actually do the same job. As I said, you can generate multiple decision trees from the same training data. Now, the classification task of decision tree is that first of all, we have the data. We use induction to create the model, and we use the training set to teach the model. And the tree induction algorithm here is the one which will be creating a decision tree. So the model here is actually decision tree, and the decision tree model will actually be used, or will apply the decision tree model, and we will be deducting the values of the classes of the unseen or the test set. Now, this is how to apply the model to test the data. So we start from the root. So we have refund, yes or no, marital status, single, divorced, married. This is the same decision tree that we've seen. Now, here we start refund is no. So it's not here, we'll go here. And the marital state is married. Then in this case, the cheat will be, in this case, no. Because yes, exactly. Because the class here will be labeled, or the attribute here will be labeled by the class no, based on the decision tree. Now, the decision tree induction has many approaches. So it's a decision tree, but we have many approaches for applying them. We have the Hunt's algorithm, we have the CART, we have the ID3, C4.5, which is called J48 on Weka. We have SLIQ, and we have Sprint. All of them are approaches to decision tree that can be applied on for induction. Now, the greedy strategy, or the heuristic method of decision tree decision tree induction, is actually about splitting the records based on attribute tests that optimize certain criterion, which means that we will be splitting records so that we will have an attribute that is tested based on certain criteria. So a greedy strategy is that we will be using, as the example when we wanted to classify using the decision tree, we actually use a certain attribute as our criterion, and it's actually we will have a subset of the attributes that will be our criterion that we will be applying on the decision tree. Now, issues regarding the decision tree induction is determine how to split the records. What are the attribute test conditions that we want to apply? Also, how to determine the best split, and to determine when to stop splitting. So all of these issues are about the decision tree, and how to specify our attribute test condition, and to especially if we have a continuous attribute, and also how or when do we stop splitting. Now, the greedy algorithm generating a decision tree. The input for this algorithm is that we will have a data. data partition, which is part of data. D, which is a set of training tuples and their associated class labels. So this is our training data. And this training data will have an attribute list, and we have the set of candidate attributes because we will start by a subset of the attributes. We're not going to be using all the attributes. Then we will need to determine the attribute selection method, which is the best partitions or the best attribute that partitions the data tuples into classes. And based on that, we will end up with the output, which is actually a decision tree. So this is the greedy algorithm. So first of all, we'll create a node n, which is the root node. If tuples in D, which is the attribute, the training data, are all of the same class. So if the tuples in in D are all belong to the same class, which is C, then we will return n as a leaf node labeled with the class C. So if all of them are belonging to the same class, then we will label them all with the same class. Then there's no need to continue. Now, if the attribute list is empty, then we will return n as a leaf node labeled with the majority class in D. And in this case, we call it majority voting, which means that we will see what is the majority. If we don't have any more attribute lists, attributes in the attribute list, then we will return the current node as a leaf node, and this leaf node will be labeled by the majority of the classes that has been assigned. So if the majority is yes, the label is the majority having a yes, then n will have a class n, a class yes. If the majority is no, then if we have, these are the available labels as yes or no. Now, these are the cases where we do not need to continue with the algorithm. So either we have all the tuples belonging to the same class, and in this case, we will give them all the same class label, or we don't have more attribute lists to look for, and in this case, we will classify the current node to be to have the majority class or the majority voting. So these are the stopping condition of the splitting. Now, here starts the algorithm. Apply attribute selection method, whichever method that we want to apply. And as I said, there are many methods, but we're not discussing that here now. And for D, which is the tuple that we are looking at right now, and the attribute list, which is the list of attributes that we are using in order to construct or generate the decision tree, in order to find the best splitting criterion. So the attribute selecting method here is responsible of finding the best splitting criterion. Now we will label n, which is the current node, with the splitting criterion that was identified in using the previous step. If splitting attribute is discrete value, okay, discrete value, and multi-way splits allowed, then so this means that we are not restricted to a binary tree, because sometimes if you notice, most of the examples that we've seen were binary tree, except for only one of them that allowed did allow more than 2 branches. So in this case, we have multi-way splits. In this case, we will remove the current attribute from the attribute list. So the current attribute that we're dealing with, we will remove it from the attribute list. So it's not going to be this splitting attribute will not going to be part of the attribute list anymore. Now we're going to start a for loop. For each outcome J of splitting criterion, so we have a splitting criterion for each tuple, in the DJ, which is the D is the part of the tuples that we're dealing with right now. Let DJ be the set of data tuples in D satisfying outcome J. So this is the splitting attribute, the splitting criterion. So we have a partition or part of the tuples that satisfy the splitting criterion. In this case, if DJ is empty, which means that we do not have any data tuples that satisfy the criterion from the subset that we identified or the partition that we identified, then we will attach a leaf labeled with the majority class in D to node N. This means that we will be applying a majority vote labeling for the D of J, because we do not have for D of J, because we do not have more attributes to look for. We're done with all the attributes within the partition. Else, attach node returned by generate decision tree for DJ and attribute list to node N, which means that if DJ is not empty, then we will be calling the same function again, which is generate decision tree, and in this case we will give it DJ, which is the partition that we identified, along with its attribute list to node N. So we will be starting again from the beginning of this function, and then end for, and eventually we'll return N, which is the decision tree. Now let's see that in an example which shows exactly the process that we've just went through. So in the example, we have the same example, which is refund, marital state, taxable income, and cheat. And we are starting by the marital state of married and single divorce. Now notice that we've created this table here showing the number of yeses and nos for each type. So for married, we have yes or no, and if you notice, this is here a binary tree. That's why we have single and divorce together, because married already have a class assigned to it, because all of the married people are actually all the married people, if they are married, then they already have a class that they do not cheat. Type. So however, single divorce will have to be branching further. Now married, so married is actually, we don't have any married tuple that actually cheated. So married and yes here, no. However, all the married instances here are no. So we have 4 instances of married and all of them no. Now single divorced, we will see that we have 3 and 3. So 3 yes and 3 no. So we will have to use another attribute to actually determine regarding if they are cheating or not. So here we said that married is no. Now we identify the refund. Refund, we notice that single divorced and refund no, we have 3. And single divorced and refund no, we have 1. Also single divorced and refund yes, we have 0 yeses and 2 no. So all of those who are single divorced and the refund is yes, we already have a label for them, which is no. So this will be no. Now regarding the no here, the refund, we will have to look at the third and final attribute, because we still have an attribute. We still have an attribute in the attribute list that we could look at, which is taxable income, and we use that. Otherwise, we will use the majority vote, because otherwise we will classify it as yes, because yes is the majority. But because we already have one more attribute in the attribute list, then we are going to use that attribute to determine the class. Now, taxable income, we discretized the attribute to being less than 80K or more than, or more than or equal 80K. In this case, less than 80K, 0 yes and 1 no, and more than 80K, 3 yes and 0 no. So in this case, it is determined that that if it's less than 80K, then it's going to be no. If it's more than 80K, then it's going to be yes. So this is how we determine the best split. So we start by any of the attributes. In this case, we started by marital status, and based on that, we identified, because here only we allow binary trees, so we identified married, okay, and then for the single divorced criteria, we will be focusing only on the single and divorced tuples, and in this case we were able to find that a single divorced along with the refund will allow us to determine part of the to classify part of the data. However, the other part of the data will need to be classified using a third attribute in order to determine its value. Now, this is an example of training data of age, student income, and by computer to know if they will be by computer or not. So I want you to construct a decision tree for this training data, and also determine the classification of this new data where age is 30 and it's a student with an income of 4,000. The income is 4,000, and you want to classify this to be by computer or not. So this will be yes or no. All right, so I'll give you 15 minutes. No, I'll give you 10 minutes to do this, and then we will discuss it and see how did you do.